Hello, everybody. Welcome back. Today we're going to be talking about Unit 3.7, which is all about solutions and mixtures. We're going to be doing some calculating today, so you're going to need your calculator. Let's get started. So let's first talk a little bit of vocabulary here, okay? When we talk about the word mixture, okay, we're talking about something physically combined with something else. It's not a chemical combination. And when we use the term solution, okay, we're talking about a very specific type of mixture, a homogeneous mixture, okay? Homogeneous would mean uniform composition. Once you've mixed these two things, you have uniform composition. It usually means something dissolved in something else, at least in AP Chem it does. Now, a solution can occur in all phases, you know. Most of the time, guys, we're going to be talking about a solid solute being dissolved, to be more specific, in a liquid solvent. But solutions can occur in all phases. You can have a gas dissolved in a liquid. You can have a solid dissolved in a gas. They can occur in all phases. However, we are going to focus most of our attention on aqueous solutions. And just to refresh your memory, an aqueous solution means water is the solvent. Okay, remember, solute is the thing that is being dissolved. Solvent is the medium in which you put the solute. Okay, so we're going to be talking about aqueous solutions most of the time where water is the solvent. This little demonstration here gets us thinking about the term molarity a little bit. Okay, molarity is the most common way to put a number on how concentrated a solution is. So if I move this little guy down here, you'll notice that the molarity right now is reading 0.000. Okay, because it's just pure water. I have not added anything to it. I have not added any solute. But let's start doing that. And you go shake, 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 shake. And I'm adding solute and I'm adding solute, and look what's happening to the concentration. It's going up, okay? Because molarity, if you look at that calculation or that formula, is moles of solute per liter of solution. And the liters of solution is staying constant, but the moles of solute, that is increasing. Okay, so I'm going to add a little bit more, a little bit more, a little bit more. All right, now I want you to think about, just conceptually, what would happen if I stop adding solute, but I start adding solvent, okay? So I'm going to open up the spigot here, and I'm going to add some more solvent, some more water. And I want you to think about what's going to happen, what should happen to that number. So here we go. Just going to add some water, okay? And did you notice the molarity went down? Okay, the moles of solute is staying the same. In this case, that's not changing, but I was increasing the total volume of solution. So if you increase the denominator, that's going to make the molarity decrease, okay? Now let's try something else. Let's say I have this open container here and I let it sit out for 2 weeks. What do you think's going to happen? Isn't some of the water going to evaporate? And yes, absolutely it is. Okay. Now, when evaporation takes place, remember that's breaking intermolecular forces between the water molecules, and it's the water only that's going into the gas phase. Nothing's happening to the solute. So if evaporation takes place, what should happen to that concentration? Let's see. Yep, it's going up, 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 up. Okay. So over time, as the solvent evaporates, the concentration is increasing. So I just wanted to make sure that you all understand not just how to calculate molarity, which we'll get to in a second, but just the concept of concentration. So I've got some practice problems here, all right? And I would like for you to pause your video and work through them and see how you do. This is review really from Chem 1 because you should have done molarity in Chem 1. Number 2 gets into a little bit of an added aspect when you're asked to find the molarity of each ion, but I want you to try it. All right, let's see how you did. I've got my answer to number 1 here, and this should have been pretty straightforward. You change grams to moles. Moles, make sure that you changed that volume into liters. Now the problem had a little bit of a thing in there to throw you off. It gave you the volume of solvent, it was 50 milliliters, but that doesn't matter. What matters is the volume of the whole solution, which is what I put in the denominator there. And you can write your final units for molarity as a capital M, or you are always welcome to write your units for molarity just like this, moles per liter. That's okay too. All right, let's look at your answer for number 2, which I didn't quite finish because I want to talk you through it. All right, I did the same process, changed the grams to moles, and then divided by liters. I want to call your attention to this line right here where you see brackets around the compound aluminum bromide. Anytime you see brackets around something, anything, an element, a compound, an ion, it means the molarity of whatever's inside. Okay, now that is the molarity of the whole compound, but the question asked, what are the molarities of the individual ions? And ladies and gentlemen, we're going to talk a little bit more about this in our next unit, but this is what happens when this solute dissolves, okay? It breaks into its 2 ions. Now that reaction right in front of us is not balanced, so I need to put a 3 right there to make sure it's balanced. And look at the ratios here. The ratio between aluminum bromide and aluminum is a 1-to-1 ratio. So guess what? Aluminum, the aluminum ion, has the exact same molarity as the entire compound. However, look at the relationship, the ratio between aluminum bromide on the left and the bromide ion. That's a 1-to-3 ratio. And the molarity of that ion is 3 times the molarity of aluminum bromide, and that comes out to be approximately this number. Okay, so if you're ever asked to calculate the molarity of an ion, you need to think about a reaction like this. How does that solute break apart? Is it balanced? And then look at the ratios. So that concludes this unit, and I hope you've learned a little something, and I look forward to seeing you next time.